Today's question is, if the system of equations, it has infinitely many solutions. So then we need to find 30 alpha beta value. So what they said, it has infinitely many solutions. Let's see how to solve. Generally what we do, if you see the system of equations, immediately you can do first and do equations to find x, y, z values. Again, if you do second and third equations like that, so when you are getting in terms of alpha and beta, then we can find alpha and beta. So like that you can do it. But here they given a condition. The condition is this system of equations has infinitely many solutions. When it has many solutions, a system of linear equations is said to have infinitely many solutions when the equations are dependent. That means at least one equation expressed as a linear combination of others. So if we have infinitely many solution, we can write the first equation is equal to the k1 times second equation plus k2 times third equation. Now using this condition, I am going to find k1, k2 alpha and beta values. Then we can substitute 13 times alpha beta. We can find this value easily. Let's do it. So what is the first equation? First equation is 2x plus 3y minus z. If this constant, if you take to left hand side, it's going to be minus 5 equal to 0. And for these two also, if you take the constant to left hand side, it becomes plus 4 equal to 0, and here minus 7 equal to 0. So this is the first equation, that is equal to k1 times the second equation plus k2 times, what is the third equation? 3x plus 5 plus beta z minus 7. Now we can compare the equations, isn't it? So left hand side we have a x, y, z and constant term, and right hand side also we have x, y, z constant. So first expand the RHS, then we can compare it. So expand the RHS. What we have? We have k1x. Then what we have? Alpha y k1. Then we have 3z k1. And finally constant is 4k1 plus. Now compare the k2 term. We have 3x k2. Then minus y k2. Minus y k2. Then we have beta z k2. Then finally constant term minus 7 k2. Minus 7 k2. So we are going to compare with the LHS. So what we have? We have 2x plus 3y minus z minus 5. So now compare LHS and RHS side. First we are going to compare x. So in the LHS what we have? We have 2. In the RHS we have k1 and k2 plus 3k2. Now compare the y. Left hand side we have 3 and right hand side we have y coefficient we are comparing. So that is alpha k1 minus k2. Now compare the z coefficients. Minus 1. Here we have a 3k1 and here we have beta k2. Now compare the constant terms. Here we have minus 5 and here we have 4k1 minus 7k2. So we got 4 equations. First I am going to find k1 and k2. So using k1 and k2, then I am going to find alpha and beta values. Then I am going to substitute in 13 alpha beta. Let's go and solve first and fourth equations. We have k1 plus 3k2 and here we have 4k1 and here we have k1. So that's why I am going to multiply by 4 for the first equation. The first equation going to be 4k1 plus 12k2, that is equal to 8. So because I am multiplying both sides by 4 for this first equation, I am taking the fourth equation, which is 4k1 minus 7k2, that is equal to minus 5. So when you do subtract, the signs will be changed. Then plus 4k1 minus 4k1 gets cancelled. So then 12 plus 7, which gives 19k2, that is equal to 8 plus 5, which gives 13. So the k2, the value is 13 over 19. This is the k2 value. K2 value substitute in the first equation, then we can get the k1 value, isn't it? So let's see first equation. What is the first equation? k1 plus 3k2, that is equal to 2. Our k2 value is 13 over 19. k1 plus 3 times 13 over 19, that is equal to 2. So k1, that is equal to 2 minus 3 times 13, which gives 39. 39 over 19. So if you take LCM here, that is 38 minus 39. So K1 value going to be minus 1 over 19. K1 value is minus 1 over 19. So using these K1 and K2 and substituting in second and third equations, I'm going to find the value of alpha and beta. So let's take the second equation, which is alpha K1 minus K2 equal to 3. What is K1 value? Minus 1 over 19. What is K2 value? 13 over 19. That is equal to 3. So here minus alpha by 19, that is equal to 3 plus 13 over 19. If you take LCM here, 19 3s are 57 plus 13, and here minus alpha over 19. So here 19 gets cancelled. So minus alpha is, the value is 70. Alpha value is minus 70. Let's go and take the third equation and find the value of beta. So what is the third equation? 3K1 plus beta K2. 3K1 plus beta K2, that is equal to minus 1. What is K1 value? Minus 1 over 19. What is K2 value? 13 over 19. That is equal to minus 1. So beta 13 over 19, that is equal to minus 1 plus 3 over 19. So if you take LCM here, then minus 19 plus 3, which gives minus 16 here. Then 13 beta over 19. Here 19 gets cancelled. So we left 13 times beta, that is equal to minus 16. So beta value is minus 16 over 13. So finally we got alpha and beta values. We need to find 13 alpha beta. So 13 times, what is alpha value? Minus 70. Let's take minus 70. What is beta value? Minus 16 over 13. Here minus term minus, which gives plus. Here 13 gets cancelled. So we left only 16 times 70. So which is 1120. So that is the value of 13 alpha beta. That's it.